Hello, calculus. We are going to talk about differential equations in Unit 7. So the first thing to note is that differential equations are, well, first off, equations that use x, y, and the derivatives of y. Equations that involve x, y, and its derivatives. So y prime, y double prime, etc. You could also see dy dx. Differential equations would arise when we wanted to know something about a relationship between maybe how something is changing, its derivative, how much of that thing is there, the y value, and how long the process has been going on, which would be the x value. We say that an equation y equals f of x is a solution to a differential equation if the equation is satisfied when y and its derivatives are replaced in that differential equation. The differential equation is satisfied when y and its derivatives are inserted. Sorry that my handwriting looks bad, but hopefully if you need, you could just rewind and listen again. Let's look at what a differential equation looks like and how we can verify solutions. This first example says, determine whether the given function is a solution of the differential equation y double prime minus y equals 0. So this, again, is a differential equation. It is an equation, because there's an equal sign, that involves a function y and some of its derivatives. In this case, y double prime. Notice above we said a differential equation can involve x, y, and its derivatives. It does not need to have all of those things, but just some. We are asked if the following equations are solutions. So this first one says, is y equals sine of x a solution to that differential equation? Well, in order to decide, we need to find y double prime. So in order to find y double prime, we are going to need y prime. The derivative of sine is cosine, and the derivative of cosine, or the second derivative of sine, is negative sine. We now take this and the original function and plug it into the differential equation. Y double prime minus y, is that equal to 0? Well, let's try it. Negative sine of x minus the original sine of x is equal to negative 2 sine of x, and that is not equal to 0. So what does that mean? That means this is not a solution. It did not satisfy our differential equation. Let's try another one. What about y is equal to 4e to the negative x? Again, we're checking the same differential equation, which means I know I need y double prime, and in order to find y double prime, I need the first derivative, so y prime. The derivative of 4e to the negative x would be negative 4e to the negative x, and the second derivative would be positive 4e to the negative x. If you don't know how I got those, you are going to need a chain rule for e to the negative x. Try those out. I know you can do it. Now we check y double prime, 4e to the negative x, minus the original 4e to the negative x. That is equal to 0, which means yes, this is a solution to our differential equation above. This is one solution. There could be many solutions. Let's look at C. Y is equal to c e to the x. Well, again, we need y prime. The first derivative would still be c e to the x, and our second derivative, also c e to the x. That means when I take y double prime minus y, in this case, c e to the x minus c e to the x, I do indeed get 0, which means this is also a solution to this differential equation. So in Problem number 1, A is not a solution, but B and C are solutions to the differential equation y double prime minus y is equal to 0. These are the notes for 7.2. Check back for the 7.3 to 7.4 notes when you have time.